Well, hello again and welcome to the VK6CS Fun with Amateur Radio channel. And to quote Jamie Heineman, and I'm sure I've done it before, when will the fun ever stop? Okay, well, for those of you waiting with bated breath to see if I actually bought a relay today, yes I did. Now I drew this circuit diagram out yesterday and said that I'd get a relay today, a mains operated relay, and I would make this circuit and see if it would work, just do a proof of concept. So I bought the relay this morning. Remember, the idea is that the AC inrush is limited through these resistors. As the transformer magnetises, the capacitors charge. This voltage here across there falls to a very low value. As that inrush current dissipates, this voltage climbs. As this voltage rises, this relay picks, and this is the relay coil for these two contacts. These contacts short these resistors out to give me full HT. And yesterday I said there was 6 volts dropped across those resistors, and I'm sure you're wondering why on earth I'd worry about that, because 6 volts here is only going to equate to, I don't know, 50-60 volts there, maybe a bit more on the HT rail. But the reason is that these resistors can't be in here when the amplifier is operating, because they'll try and limit the current. When the amplifier is running power, these things will burst into flames. They will turn themselves into stalks, and my amplifier will sound like a box of cornflakes. So the current limiting resistors, the inrush current limiting resistors, do need to be switched out. Right. So I'll just show you what I've got here. Now this does look like a bird's nest. You might actually see a beak protruding here and there, where a passing squadron of vultures has decided to make themselves at home. But it looks like a bird's nest, but electrically it's the same as that diagram I just showed you. Now this is turned off. Here's one of the 3.3 ohm resistors, here's the other one over there, and there is the relay. Now what I've done is, because this is just a lash up just to prove the concept of this, I've just soldered on the ends of the 3.3 ohm resistors on each side, on this side as well. I don't know if you can see it there, just a bit of 1mm building wire sticking out there, because I've got to solder a couple of wires on here and a couple of wires on there as well. Now it doesn't have to look great, just has to be robust connections, so there's no dry joints there. It's all pretty good. So the mains comes in here, active goes up here through a 8 amp fuse here, and then back down through to this chocky block. So my mains voltage is going across the 2 red wires there to the resistors, goes through the resistors, comes out the other side, and on each side, on each resistor, is a red wire going to my transformer primary, and the other 2 red wires that are connected to exactly the same spots effectively across my transformer primary is the relay coil here. Right, okay, so I hope that makes sense. Now, where am I going? Where am I going? I want my metering. Where's it gone? Okay, there we are. You know what they say about a cluttered workspace? What was it Einstein said? If a cluttered workspace indicates a cluttered mind, what does an empty workspace indicate? So I'll have a cluttered one any day, thank you very much. Right, here we go. Bit of focus on there, my usual standard preparation, fire that up. Now, I'm going to fire it up. Now, when I fire it up, you will hear a very nasty noise. Certainly not the sort of noise you would hear coming from a commercial amplifier. And in a minute or two, I'll tell you why. Okay, got your fingers in your ears? Ready? Here we go. Oh, that sounded terrible, didn't it? It sounded like it was about to burst into flames. Okay, well, I'll explain that in a second. and I'm not obviously going to leave it like that. That's totally unacceptable. But while I'm here, I will measure using my super safe EHT probe the HT voltage, and the HT voltage is, now this remember is with the resistors shorted out. So this is with the relay, the 240 volt relay energized and shorting out those two 3.3 ohm resistors. I get 2.77, which is, remember that's times 1000, that's 2770 volts, and that's about what's being indicated on there. So that's all looking good. Okay, so now I'll just turn the AC off. And I'll disconnect the relay coil. Open circuit that relay coil, so when I fire it up next time, you can probably see this all moving around. I'm just trying to pull the lug off the bloody coil, and of course it's being, there we go, particularly stubborn. I'll just quickly show you that what I've done there. Okay, so what I did then was I just pulled that off. That was on there on the relay coil, and I pulled that off. So that's now open circuit, that relay. So now we go back to our metering. My metering is down here amongst all this rubble. I'm sort of preempting the inevitable explosion, of course. Now it doesn't matter that the HT voltage hasn't gone to 0, because what I'm going to show you now, we're not really interested in the inrush, we're only interested in the HT voltage. So remember now, when I apply, when I turn the mains on, the resistors will not be taken out of circuit by the relay. They'll remain in circuit. And you see the light dim with all those watts that will soon be throbbing into the antenna, pulling down my mains voltage. Right, now we'll see what the difference is. Now with the resistors in, going with the EHT probe, put that on there. 2730 volts, 2.73. Remember that's times 2730 volts. So the difference between 2730 volts and 2770 volts pretty negligible, but those resistors do have to be switched out, because once the power supply is loaded up, be quite a lot of current going into that primary, and those resistors will be pretty unhappy. They'll get extremely hot, and they'll limit the current. Well, while they're for as long as they last, they'll limit the current going into the actual amplifier. So they've got to be switched out. That's why I'm fudging around, switching out resistors that are only dropping the HT line by 30 or 40 volts. If you remember yesterday, I said there was a 6 volt drop across those resistors, so it's not going to be much of a difference whether they're in or out with regard to the actual HT rail voltage. But the problem arises when the power supply is loaded up. They just can't be in circuit when under those circumstances. Right. Now I'll turn that off, and that can be draining away while I explain what that bloody awful noise is. Now, I'll get that round. Here we go. Sorry about the creaking and groaning on this, but I found that if I actually loosen the tripod up on the camera flops around all over the place, so I have to leave it tightened up, and that's why it makes the creaking and groaning noises when I move it around. Right, back to the circuit diagram. And what I need is something a bit smaller. Something a bit smaller. Oh, here we go. I use the pen again. Right, so what that bloody awful noise is this relay coil is the specification for it says that it picks at 192 volts. I actually tried it with the Variac. It picks at about 140, 150, and it starts thinking about picking at about 130. So what's happening is the actual concept works a treat. The inrush current here pulls this voltage here down to a nice low value. As the inrush current dissipates, this voltage goes up, but it doesn't go up fast enough. It actually goes up too slow. And what's happening is, what that buzzing noise is it comes up to a point where this thinks about picking, and then it stops buzzing when it picks. So that is the time it takes for that voltage to go from, oh, I think I might pick, to I've picked. And I'm hoping that this rise in voltage is not a linear rise. I'm hoping it's an exponential rise, because if it is, what I'll do is I'll take this relay out. This relay is a 4,500 ohm coil, and I'll put one in that I've seen from another local electronics store. They do a 240 volt relay with a 15,000 a bit ohm coil, and that will not pick until the voltage is sort of up here. This picks down here, thinks about picking here. I want something that says, oh okay, I'm going to pick about here, and then it should just go click and not think about it for a second. That's what I'm hoping. Now it may be, because I haven't seen this arrangement used anywhere, that's why people don't use it, because you can't get rid of that. If that's the case, I'll go back to a DC arrangement. It's a bit of a fiddling around, because this transformer doesn't have any low volt windings I can use for that, so I'll have to do it with the HT. Push comes to shove, I'll do that, but I would prefer to do it like this. So I'll get another relay, and if the other relay just goes click when it gets to a certain voltage, then I'll be delighted, and that will be a line drawn under that, and then I'll have the circuit diagram that I'll actually build, and get rid of the bird's nest and build it properly. Okay, well I think that's about it. I'm sure you're all sitting on the edge of your seats waiting for the next thrilling episode of the VK6CS HF amplifier power supply story, but I don't know whether I'll be doing any more of it this weekend. I'll see how I feel tomorrow. I can't get one of the relays. I can't get one of these other relays tomorrow, unfortunately. So that test experiment, call it what you will, we'll have to wait until, I don't know, it might even be next weekend, so I'm not even sure I'll be able to get to this place during the week to pick up one of these blooming relays. If I can, I will, and if I can't, it's just going to have to wait until next week. And if that's the case, I've got a couple of other things I can be getting on with, just in case you have an insatiable appetite for VK6CS videos. Yes. Yeah, okay. What's the average? 10 views, I think, per video, something like that. Alright, well, thanks for watching. Hope you found that interesting, and I'll catch you next time.